Sorry, let's take a look at this trig identity. So we got, again, we have our left side is equal to our right side. You'd be surprised how many times I mess up my left and right on this thing. But left, right, okay, we got that. I'm going to work on the right side here. To me, it's going to be a bit of a simpler move over to the left side. Some of the things I kept in mind is that there's a negative on this side. So I want to use one of my trig identities that incorporates an addition or a subtraction sign. So though I can use like quotient identity with tan, okay, so I'll write the identities quickly on the side here. Technically, I could say tan x is equal to sine x over cos x. That doesn't incorporate any addition or subtraction. So the other identity I thought about was sine squared x plus cos squared x is equal to 1. And then I can just kind of rejig that to be equal to sine squared x. So sine squared x is actually equal to 1 minus cos squared x.
I think I see this.
Yeah. So I'm going to replace just that with 1 minus cos squared x. So we're going to work on the right side
no,
here.
I don't see this.
No? Okay, don't worry. We'll get it there. So I'm going to replace that. So that's now going to become 1 minus cos squared x, okay, times tan squared x. So from here now, okay.
Is this on the right side?
Yeah, I'm working on just the right side. So I replaced
tan squared x.
I replaced just that part. So the tan squared x stayed.
Oh,
okay. And I replaced just the sine squared x with the 1 minus cos squared x. So now that I've done that, I'm actually going to use distributive property. I'm going to distribute the tan into both. And I know this isn't the most organized version right now, but I had some identities we just kind of drew in the middle. So consider these like they wouldn't be on your page. We would have just dropped right down to that step. So when I distribute the tan, I get tan squared x minus cos squared x times tan squared x. And I'm going to take a quick peek at my other side. This is really good. I have a tan squared x as essentially the first term, and I have a subtraction sign, but this is just left with sine. I need to essentially turn this into some version of sine. Well, I know I can incorporate sine by using my quotient identity again, so I'm going to replace tan with the quotient identity. So I get tan squared x minus cos squared x times, this is replaced with our sine squared x over cos squared x. And because this is essentially multiplication, this value here kind of eliminates with this one here. I could actually bring it into the bracket if you wanted to see it in all of the steps, but these two things, they eliminate. So if I was to multiply, again, this is a negative cos. So if I was to actually multiply this forward, it would look like this. So I'll actually draw that step in if you're kind of unsure. We'd have tan squared x minus cos squared x sine squared x, everything above cos squared x. And now because, think of this whole thing as negative, because these two are the same in its multiplication here, this eliminates into the value of 1. And 1 times sine is just the idea of sine. So I have tan squared x minus sine squared x, and that's exactly what my left side of the equation originally said. Did it? Tan squared x minus sine squared x? Yes, that's it.